I'm now moving on to the homework questions for the Polynomials chapter. And for question number 1 in the first homework assignment, I need to match the description on the right with the expression on the left. And some answers may have two descriptions. Okay, let's take a look at question 1a. With 1a, there's a variable on the denominator. Whenever you have a variable on the denominator, it's not a polynomial. So for question 1a, it takes option number 5, which is a non-polynomial. All right, let's move on to 1b. For 1b, there's two terms. So if you have two terms, that's a binomial. So this will be the answer for B, option number 2. For option number C, we have a few cases for option C here. Because you don't have a plus or minus within those two variables, that's considered one term, so that's a monomial. So monomial could be used, but also it could also be a polynomial of degree higher than 2, because if I take a look at the x, and if I take a look at the y squared, that's kind of like 1 plus 2, so my degree here is actually 3. So since my degree is 3, it actually matches up with option number 6 as well. It's a polynomial of degree higher than 2. So option number 1 works, and option number 6 works as well. Okay, great. Let me just erase this, and then we'll move on to the next few letters here. All right, let's move on to option number D. Now for letter D, I have an x and a y next to each other, but they're not separated by a plus or minus sign, so it's all clumped together, so that's considered one term. And if you're one term, then it's considered to be a monomial, so it's option number 1 only. The degree here, if I combine the two variables, x and y, the degree would be 2, so it would not fall in under the old category, option number 6, which was the case for the previous problem, because the degree is not higher than 2. Okay, let's move on to option letter E. Now for letter E, there's one variable with the y, and here's another variable with the x. So those are two terms. So if you have two terms, that's considered a binomial. So binomial, that's the term when you have two terms. And we also have another answer here. It's actually option number 4 as well. It's a polynomial with leading coefficient of negative 4. And the reason why it's a negative leading coefficient of negative 4 is because if I rearrange this, I can rewrite this as negative 4x squared plus 6y, so that the leading coefficient here is negative 4. So this is actually option number 4 as well. And because there's a 2 here, 2 is higher than this power 1 here, so we always want to arrange the polynomials with the highest power there, so that's why the negative 4x squared would come first, and the leading coefficient on that is negative 4. Okay, let's move on to the last few here, and I'll just erase all these terms so I have a little bit more space to work with. Okay, so let's go on to letter F here. So with letter F, there's 1, 2, 3, there's 3 terms. So if you have 3 terms, you are dealing with a trinomial. So this will be option number 3. And we also have option number 7 as well, because it is a polynomial written in descending powers of x. So that's pretty obvious here, because this is a power 2, this is a power 1, and this is a power of like x to the power 0. So I go from a 2, a 1, and a 0, so I am decreasing in power. So option number option number 7 will also work for that particular problem. Okay, for letter G. For letter G, there's only one option here. Although there are 4 terms, we don't have any options available for 4 terms. But it is a polynomial written in descending powers of x again. So for letter G, it's going to be option number 7. And all you have to do is look at the powers here. That's a 2. This power here is a 2, this power here is a 1, and this power here is going to be like x to the 0, so that's just 0. So I go from a 2, 2, 1, 0, so that's also written in descending powers, and that fits in option number 7 there. And finally, the last one here, I have 3 terms, 1, 2, 3, so if I have 3 terms, it's simply going to be a trinomial. And there's nothing to worry about the powers there. It doesn't really match any other options, so trinomial for letter H. Okay, let's move on to question 2. And for question number 2, I only ask you to do a few select problems. So for this problem, I need to determine if the expression is a polynomial or not. So for 2a, the answer is going to be yes. If you have a variable and a power, then those are always going to be polynomials. For letter 1b, I mentioned in the previous problem, if your variable is on the denominator, then it's not a polynomial. Question number, letter C, 2x squared plus 3. Yep, you have variables, you have numbers and constants. You have a positive power there, so yes, that is a polynomial. For letter H, well, you can rewrite this as x squared plus x plus, well, x to the power 0 is just 1, so I see variables, I see numbers. Yeah, nothing wrong with that one. This is a polynomial. For letter I, we do have a problem here. The powers here are negative. If you have negative powers on your variables, then these are not polynomials. Polynomials always have positive powers, or in this case, you could also have, you could also have 0 as a power as well. But the general rule is you want to have positive powers, and those are common characteristics of a polynomial there. So that one there is going to be no. Okay, let's move on to question number 3. Determine the degree of each polynomial. Now, before we start off with this problem, because we need to determine the degree, all of the examples on question number 3 are polynomials. All right, so a lot of them will have variables, numbers, and positive exponents. Those are the common characteristics of a polynomial. Okay, let's move on to question number 3a. What's the degree? Well, the degree is the highest power. So for 3a, this is the highest power. So my degree here is going to be 2 because that's the power. All right, so we always look for the highest power. For letter B, we have to be careful here because this is 2 to the power 3, which is 8, plus x squared. And we're always looking for the highest power on the variable. So this 2 is the highest power, so my degree here is 2. Now for letter C, negative 5, I can rewrite this as negative 5x to the power 0. And the highest power on the variable there is going to be 0, so this will be just 0. Remember, x to the power 0 is just 1, so this is the same thing as negative 5 times 1, which is negative 5, which is the original statement. But I'm going to rewrite that with x to the power 0 because for the degree, I need to look at the variables and their powers. Okay, for letter D here, 3 squared, well, that's 9. And then it has an x with the power 0 because x to the power 0 is 1, which is still 9. But the highest power in the variable is 0, so my degree here is going to be 0. Okay, let's move on to the next one here. Let me just erase that. One little tricky part here is 2 cubed. Well, 2 cubed is 8, so 8x minus xy. And if I take a look at the x and the y, each variable has a power of 1, so if I combine that, that's going to be 2, so my degree here is going to be 2, because 2 is the power in the variable. Key thing, we always look at the variables. For letter F, here's a variable right here, x squared, so 2 is the highest power out of all the variables, so my degree here is 2. For the next one here, this is going to be 7x squared plus, now 2 to the power 5 is going to be 32, it's just a number. It doesn't have a variable. But here's my variable, and the highest power on that variable is 2, so my degree there is going to be 2. Okay, for letter H, here's my variable here, 5x squared, and the highest power there is 2, so my degree is going to be 2. And for letter I, there's only one variable, and the highest power on that variable is 0, so this will also have a degree of 0. And finally, for letter J, here's my variable x squared, and although there's another variable here, the power here is greater than that one, so the highest power here is going to be just 2. Okay, so those are a few practice questions on some theory problems with polynomials, and we'll definitely do a lot more in class. All right, let's move on to question number 4 here. Determine the coefficient of each monomial. All right, so monomial, this just means one term. And these are all going to be polynomials because monomials are also polynomials. All right, coefficient is basically the number in front of the variable, and that's it. So for question 4a, the coefficient is going to be 2. For letter B, the number in front of the variable is -8. For letter C, the number in front of the variable is 1.9. For letter D, 2/3 is the number in front of the variable there, so the coefficient is 2/3. For letter E, that's -7/2. For letter F, it's going to be 3.7. For letter G, now for letter G, if you want to rewrite this with a variable, you can write that as -8, x to the power 0. And remember, x to the power 0 is just 1. So if I do -8 times 1, it's still -8. But yeah, you can see here that the number in front of the variable is just -8. So this will be -8. And for letter H, I can rewrite this as 0x to the 0. And yeah, so the number from the variable in this case is just 0. So this coefficient is going to be 0 as well. All right, so that was a pretty quick one. And let's move on to the next few questions. All right, let's move on to question number 8. We need to simplify. All right, so when we're simplifying, a lot of times you need to collect the like terms. So let's write that down. You want to collect like terms. And when you're collecting like terms, all you're doing is just adding or subtracting. So most of these questions on section 8 have to do with your ability to add or subtract numbers. All right, let's take a look at question number 8a. So let me just circle the like terms here. So here's the like term. And then we have, okay, so 2x minus x is going to be a single x. So those guys can cancel off. And then you have a -3 plus 2. -3 plus 2 is going to be -1. So your final answer there is x minus 1. For question number, letter C, let's circle the like terms here. These are like terms because they all have x squared. Now ask yourself, what's 2 minus 1? Well, 2 minus 1 is just 1, so 1x squared. Those are gone. And then you can look at the plus x and a minus x. So in class, sometimes I say you have 1x box and you lose it, so then nothing remains. So your final answer is 1x squared, which is just x squared. So these guys just cross off. Okay, letter E now. Let's circle the like terms. Okay, well, there's a -4x squared. That does not have a like term, so I can rewrite it down here as -4x squared. That goes away now. Here's a -3x and a plus 2x. So -3 plus 2 is going to be -x. So -3 plus 2 is actually -1. So -1 with this like term is going to be -x. So those go away. And then you're just left with a positive 4. And then you just tag the positive 4 there at the very end. Okay, so not too bad. We're just adding and subtracting a lot of these questions here. All right, for letter G, here's a 4x and a -5x. So 4x minus 5x is going to be -x. Those cancel off. Oh, sorry, let me just repeat that question again. Sorry. There's a 4x here. There's a plus 6x and a -5x. So let's combine all of that. So this is going to be 10x. And then 10x minus 5x is going to be 5x. And then finally, you have a -3y, so final answer is 5x minus 3y. Okay, let's move on to the next one. For the next one, if you want to rewrite this as 3xy minus 4xy plus 2xy minus xy, you can do that. That way is very easy because all of these are like terms, so just look at the coefficients here. And we're just summing up all the coefficients now. So 3 minus 4 is -1. -1 plus 2 is 1. And then 1 minus a 1 here is going to be 0. So my final answer here is 0xy, which is simply going to be just 0. Okay, let's move on. Letter K now. Okay, for letter K, my like terms are 13x and -4x. So that's going to be 9x. If I combine those, 13 minus 4 is 9x. Cross those guys off. -7 plus 2 is going to be -5. All right, let's move on. For letter M, well, these are both like terms. So all you're doing is you're just adding the fractions here. So if I do 2/3 plus 1/3, that's going to be 3/3. So my final answer is 3/3x, which is now going to be 1x. And 1x is just a single x. So there's my final answer for that one. Okay, let's move on to letter O here. Now for letter O, these are all like terms because they have the x's, but we have a fraction here, 1/2, so we might have to write everything in terms of a common denominator. So there's a 1 here, so 1 will be the same thing as just 2 over 2, and then the x, minus, well, this is a 5. 5 is really the same thing as 5 over 1, and if I want a common denominator of 2, I can times that by 2 and times that by 2, so that'll be 10 over 2. So this will be 10 divided by 2x. Now you'll notice that all the denominators are the same, and now we can just combine the numerators. So 1 plus 2 is 3, and 3 minus 10 is going to be -7. So -7 over 2x. That's my final answer for letter O. Okay, let's move on to letter Q here. Let's go ahead and circle all the like terms. So here's an 8x, a -5x, and a -2x. If I combine that together there, well, 8 minus 5x is going to be 3x, and 3x minus 2x is going to be a single x. So I have an x to start off with. If I combine all the x's, 8 minus 5 minus 2 is just going to be 1x, or just x. So now those guys are gone. And then I have a plus 3y by itself. And then I have finally, I have a plus 4 minus 7, which is going to be -3. So x plus 3y minus 3. All right, letter S. Let's go ahead and combine some like terms again. So this term and that term, those are like terms. So -2 plus 5 is going to be 3xy. Those will cancel off. And then here's a plus 3x and a -x. So 3x minus x is going to be positive 2x. And finally, I have a -2y minus y. So you can think of that as -2 minus 1, which will be -3y. All right, so that concludes question number 8. Those ones aren't too bad. And finally, we are now going to finish off this section with question number 10. And for question number 10, there's just a few more of these simplifying polynomials by collecting like terms. And the only challenge here is you have a few fractions, and you just need to stick with your fraction rules when you're combining like terms with those type of problems and numbers. Okay, so let's take a look at the like terms here. I have a plus 15a squared and a minus 3a squared. So 15 minus 3 is going to be 12a squared. So those guys will now cancel off. And then I have a -a and another -a. So that's kind of like -1 minus 1, which is going to be -2, and then -2a because they both have the variable a. And then finally, you need to add 3/4 minus 1/2. So let's just do that calculation on the side here. So 3 over 4 minus 1/2. Okay, so you can just times this by 2. So now you have 3 over 4 minus 2 over 4, which equals to 1 over 4. All right, so let me just add a plus 1 over 4 here, and that should be my final answer for that particular problem. Okay, moving on to letter C now. Let's go ahead and find the like terms. Here's a -c squared and positive 7c squared. So -6 plus 7 is going to be 1c squared. Those will cancel off. And then I have a plus c and a -5c. So that's the same thing as 1 minus 5, which is -4c. And those will cancel off. And then there's a plus 1 at the very end. And you can rewrite this as just c squared minus 4c plus 1. That's a polynomial, degree 2, and it's a trinomial because there's 3 terms. All right, let's move on to the last question in the homework here. And let's go ahead and circle our like terms again. So here's a 2e and a -2e. Those will just cancel off. 2 minus 2 is 0. And then we have a positive e there. So I guess I'll have a single e to start off. And then I have a plus 4e squared. So plus 4e squared. Those are all done. And then finally, I need to combine the -5 over 6 and the 1/3. So let's do that on the side over here. -5 over 6 plus 1/3. You can times the top and bottom here by 2. So now you have -5 over 6 plus 2 over 6, which equals to -3, which equals to -3 over 6, which is equal to -1/2. So I'm going to put -1/2 here at the very end. And if you want to write this in terms of highest powers, it would be 4e squared plus e minus 1/2. And that right there is your final answer. All right, so that concludes this video for adding polynomials.